Okay, yesterday when we were looking at graphing, we looked at velocity time graphs. We found out that the slope of the line on a velocity time graph ended up being acceleration. So from that, we can see that our acceleration is rise over run. So remember on our graph, if we had velocity and time, our line of the graph was our acceleration. So we did rise over run, which would be the velocity over time, or change in velocity over time. But the formula we're going to use most often for change in velocity is velocity final minus velocity initial. The time really doesn't matter because usually they'll just say that happens in 3 seconds or whatever, but it would be the same if you had a graphing situation. You could subtract the 2 times, the final minus the initial as well. We also talked about our units for acceleration as being in meters per second squared, because we have velocity on top, meters per second, and then we're dividing by time on the bottom, which would be seconds. But instead of writing it as meters per second, we usually just combine the 2 seconds and make it meters per second squared. One other tip, if you get a question that deals with kilometers per hour, you want to change those kilometers per hour to meters per second first, so do that right off the bat, then plug those into the formula. So you'd have meters per second minus meters per second divided by seconds, and then the question should be good. So let's just do a couple of quick examples using the new formula. So our acceleration formula that we want to use is final velocity minus initial velocity divided by time. So for this example, we would go, it says a person's running, they accelerate from 4 to 7, so our final would be 7, initial is 4, and that happens over half a second. So we just type that in on our calculator, and that'll give us an answer of, so 7 minus 4 divided by 0.5 is 6. And we have one significant digit in the question, so we'll keep our final answer to 1 as well. So we'd have 6 meters per second squared for that answer. Let's do another one. So be careful with acceleration, because our acceleration can be a change in velocity like the last example, but we also have to be careful of change in direction, because acceleration and it can be the change of velocity or direction. We have to be careful of both. So when you're doing this question, what you want to do is, we have the car, it's rolling at 2.5, so let's assume that is a positive direction, and we're bringing it to a stop, so that would be a velocity of 0. So when you plug this one in the formula, your final velocity is 0. The initial will be 2.5, and we did this in 8.5 seconds. So you just got to be careful with this one, because we went from 2.5 down to 0, so we should actually have a negative acceleration. So we'd have negative 2.5 divided by 8.5 gives us an answer of 0.29. And we want to have 2 sig dig, so 0.29 is good. So we have 0.29, but because of that negative, we have to keep the negative in our final answer. So our final answer should be negative 0.29 meters per second squared. Okay, so just be really careful of the final minus initial. If you do it in the right order in the formula, the positive and negatives will take care of itself. So let's do one more that's similar. So this one we have the same car. So the car was rolling towards us. We brought it to a stop. Now we're going to push it backwards at a velocity of 1.25 for 3.2 seconds. So in this case, our final velocity is 1.25, and our initial is 0, right? Because it was initially stopped. We stopped the car. Now we're going to take that stopped car and push it backwards. So you have to be careful with this one, is our final is still negative because we're going in the opposite direction. We're going backwards. So you have to put that velocity in as negative 1.25. Our initial was 0, so we don't have to worry about that. And our time is still 3.2. Okay? So when we do that on the calculator, we get 1.25 negative divided by 3.2 is negative 0.39. And we want 2 sig digs, or 3. We want the least, so we want 2. So negative 0.39 meters per second squared. So these two examples are very similar, but they're different in the key idea of direction and whether it's going to be positive or negative. So the first one, the car is going forward, but we're slowing it down, we're bringing it to a stop, so we'd have negative acceleration. The second one, we're going from 0 to 1.25, so it's speeding up, but we're going backwards, so that one's also considered negative. So just like we were looking at yesterday, be careful of your signs. So if you have positive direction and speeding up, you'd have your positive acceleration. If you have positive direction but slowing down, you'd have negative. Negative direction and speeding up would be negative. Negative direction slowing down will end up being positive. But the good news in the formula is if you get your final and initial speeds correct and you get your directions correct, the math will take care of itself and you don't need to worry about changing your final answer to be positive or negative. And that's all for today.